All right, today we're going to talk about two-way tables. So it's another way to organize what we call bivariate data, where there are two categories or two variables. So similar to scatter plots, but organized in a different way. A two-way table displays two categories of data collected from the same source, which is also true of scatter plots. A lot of times that source would be a person. So you're asking them two things about one person. And that's not always the case, but it is often the case. So let's go ahead and take a look at an example. Let me see if I can scroll up here real quick. All right, here we go. So first, let's go ahead and fill out this table, and then we'll talk about the rest of the vocabulary on the slide. But really what we're seeing here is these students were asked if they studied or didn't study and whether they passed or failed a test. Okay, that's what we're looking at here. So 21 studied and passed, 2 passed but didn't study, 1 studied and failed, and 6 failed but also didn't study. Okay, so they were asked those 2 questions, but each data point is just 1 student. So really what we want to do here is fill out the totals. So total that passed would be 23. You're just adding those together. Total that failed would be 7. Then you can total that studied would be 22. Total that didn't study would be 8. And then no matter if you add across or down, your grand total of people that were asked is 30. Okay, and when it's just in these whole numbers like this, we call it the frequency distribution. Now, what we do after we have a frequency distribution is we tend to look at the relative frequency, because percentages are going to make our data more applicable to other situations if we can see what percentage of people, because not every class is 30 students, for example. It helps us apply our data to more situations. So if I want studied and passed, what I would do is I would take 21 divided by 30 times 100 to get a percentage here. So let me go ahead and pull up a calculator. All right, 21 over 30. So 21 divided by 30. And then for percentages, you want times 100. So this would be 70%. 70% of students passed and studied. Okay? 2 out of 30 times 100 is 6.67%. Let's go ahead and do 6.67%. We're going to do 2 decimal places if they don't just end. If we need to round, we'll do 2 decimal places. And then you can do 23 out of 30, or you can add these. Either way you do it, 23 divided by 30 times 100 is still going to be 76.67. So I often find it easier just to add them. Let's clean that up. .67%. Okay, failed. So 1 out of 30 times 100, 3.33%. Okay, and then if you add those together, that total would be 73.33%. Okay, and then we have to do 6 out of 30. Is 20%. So total here would be 23.33%. And total here would be 26.67%. And your grand total for percentages should be 100. Now sometimes they're 99.9, sometimes they're 100.1, and they're different because of rounding error. So if yours turns out to be 99.9 or 100.1, that's okay, but any larger or smaller than that, you probably have an incorrect calculation in there. All right, so there's our two tables. So let's talk about the rest of the vocabulary. So this is a normal frequency distribution, and this is a relative frequency distribution. So the ratio or percent an event occurs. So sometimes they'll leave them as a fraction or a ratio. Okay, fractions are ratios. Sometimes they'll go ahead and turn them into percents. I prefer the percents, so that's what we're going to do on your homework and on your tests. Joint relative frequency is a frequency not in a row or column total. So I'm going to highlight here joint relative frequency. And relative frequencies are always these percentages, but they're saying that not in a row or column total. So these four that we actually calculated and didn't add up, those are joint relative frequencies. A marginal relative frequency is the sum of a joint in a row or column. So that would be these edge cases here. Okay, so totals of rows or totals of columns. A conditional relative frequency. These are usually harder for students to understand, but you're not going to be using the grand total if it asks for a conditional relative frequency. So it's the ratio of a joint to a marginal using a row or a column total. So remember, the joint is what we've highlighted in yellow. Marginal is green here. And you're using a row or a column total. For this whole entire table, we use the grand total. So if it's a relative frequency and they don't specify, you'll use the grand total. But for example, if they ask for the percent of failed students that did not study, you would take the failed total because it says of failed students. So we would use the failed total and the ones that did not study. So instead of out of 30, we would take 1 divided by 22. 1 over 22 times 100. Okay. 1 divided by 22 times 100. So that would be 4.55%. For example. Okay, so a lot of vocabulary there. All right, so a new example. So in this case, we're talking about students that attended a football game or a dance. So again, they're asking one student and they're asking them about whether or not they went to the dance, the football game, neither, or both. Okay, so they collected data. So 35 attended both, 5 attended the dance but not the football game, 16 attended the football game but not the dance, and 20 attended neither. So that's what our table is saying. So for this first one, they just want us to total up. So 35 plus 5 is 40. Here we'd have 36. Here we would have 51 and 25. And again, no matter which way you add, either vertically or horizontally, you should get 76. If they don't agree, you made an addition error somewhere. All right, so if we're going to make our relative frequency table, we're going to do that by dividing by the grand total times 100. So for the first one, we'd have 35 divided by 76 times 100 is 46.05%. 5 out of 76 gives us 6.58%. And then you can just add those, or you can divide. Both ways should give you 52.63%. Okay, if I took 40 over 76 times 100, I would still get that. Okay, next row, 16 out of 76 times 100 is 21.05%. So if I add that to 46.05, I will get 67.10. For this one, 20 out of 76 times 100 is 26.32%. Okay, so if I add this direction, I would get 47.37. And if I add straight down, that gives me 100 even. Remember, you can be 100.1 or 99.9 because of rounding error, but 100 is the goal. And if I add this way, I get 32.90%. And these two would also add to 100 if I added this way. All right, find the percent of students that attended the dance and football game. So attended both, and it just says of students. So that's how I know that I can use my normal relative frequency table. It didn't say find the percent of football game attendees or find the percent of dance attendees. It said find the percent of students, which means our whole total, that attended both the dance and football game. So for us, that'd be 46.05%. And then it says find the percent of football attending students. So of football attending students, so total that attended the football game, right here would be 51. Football game attended, total is 51. That also attended the dance. So we want to take 35 out of 51 times 100. So you got to pay attention to how these questions are worded. If it's the grand total or a different row or column total. So 68.63% for that one. All right, let's look at one more example for today. This one we have bus riders and their age categories. So keep in mind a group of tallies is 5. So this would be 5, 10, 15, 20, 24. So 24, 12 to 13-year-olds. Then here this would be 12 and 14. And then doesn't ride bus would be 16, 13, and 5, 10, 15, 20, 21. Okay, then we would total these up. So that'd be 36 plus 14 more is 50. 29 plus 21 is 50, so 100. So it'd be 35, 25, and 40. And this should also add to be 100. Okay, then relative frequency. What is really nice about the total being out of 100 is that when you divide by 100 and multiply by 100, this 24 out of 100 is 24%. This is 12%. So this table right here is going to be exact same, just percents. So I'm going to go ahead and pause and fill that out, and then we'll answer the 2 questions below. All right, so again, this is our frequency table. This is our relative frequency table, but because the grand total was 100, they really look the same. And then it says, find the percent of students ages 16 to 17. So this is going to be one of those where we're going to use the 16 to 17 total because it doesn't say of bus riders or of students. It says students ages 16 to 17. So we want 30 out of 35, 14 ride the bus. So we would take 14 divided by 35 times 100. Is 40%. And then last question, find the percent of 12 to 13-year-olds. So we're going to use that 12 to 13-year-old total that do not ride the bus. So we'd take 16 out of 40 for that one. Oops. So 40% again. Just a coincidence. All right, that's it for our notes today. You can move on to your assignment.